Okay, here are some major takeaways from the video that we would have talked about in class today. So the first is that the domains of y equals cosine of x, well, y equals sine of x, y equals cosine of x, and y equals tangent of x were restricted so that their inverses would be functions. Okay, so because of this, there are major restrictions on what the answers to their inverses can be. Okay, so this means that when you're asked to find the inverse sine of something, so the output of inverse sine of x has to be an angle from negative pi over 2 to pi over 2. It can be negative pi over 2, and it can be pi over 2, or from negative 90 degrees to 90 degrees. So it can be negative 90 degrees, and it can be 90 degrees. Okay, similarly, let me get a new slide here. So the output of y equals inverse tangent of x has to be from negative pi over 2 to pi over 2 in radians, or negative 90 degrees to 90 degrees. Okay, so the output of inverse tangent, well, tangent of negative pi over 2 is not defined, so that means negative pi over 2 is not going to be an output of inverse tangent. Tangent of pi over 2 is not defined, so pi over 2 is not going to be an output of inverse tangent. Okay, so again, the output of inverse tangent has to be an angle between negative pi over 2 and pi over 2, or negative 90 and 90. Finally, we have inverse cosine. So the output of y equals inverse cosine of x has to be an angle from 0 to pi over 2, 0 to pi, or 0 to 180 degrees. Okay, so if you're asked to give a value of inverse cosine of x, it has to be in this interval or in this interval. Okay, so let's do some examples here. Right here we want to find the inverse sine of negative 1/2. Okay, because of the restrictions I just told you about on inverse sine, when we want to use the unit circle to find that value, we use the right half of the unit circle. Okay, so to find the output of inverse sine, we use the right half of the unit circle. And I would like you to put that in your notes right now. Okay, to find inverse sine of negative 1/2, well, negative 1/2 is in quadrant 4, so we're looking for where the y-coordinate here is negative 1/2. That's this number. So whenever we're in quadrant 4, to get the answer, we start at the x-axis and rotate clockwise until we get to it. So our answer is going to be negative since we're rotating clockwise, and it's the negative whatever angle we have to go through. So this is going to be negative pi over 6, because that's what we have to go through. Okay, you'll see that the sine of 11 pi over 6 is also negative 1/2. But 11 pi over 6 is not a number between negative pi over 2 and pi over 2, so it's not a possible output of inverse sine. There's one answer to inverse sine of something, and that's because inverse sine of x is a function. So it has one and only one answer. Okay, you find inverse tangent similarly. So let's do inverse tangent of negative root 3. Okay, the output of inverse tangent also comes from the right half of the unit circle. So please put that in your notes. The output of inverse tangent comes from the right half of the unit circle. We want inverse tangent of negative root 3. So we find out where the y divided by the x is negative root 3. And we see that that happens at this spot right here. So like sine, we start at the x-axis and rotate clockwise to get to it. And we have to go through pi over 3 radians. So since we went clockwise, the answer is negative. and it's negative however many radians we went through, so that would be pi over 3. Okay, let me talk about inverse cosine. So let's do inverse cosine of, say, negative root 3 over 2. Okay, because of the restrictions on cosine, the output of inverse cosine comes from the top half of the unit circle. Please put that in your notes. The output of inverse cosine comes from the top half of the unit circle. You start at the x-axis, positive x-axis, and rotate counterclockwise. So the output of inverse cosine is always going to be a positive answer. Okay, so now let's locate where is the x-coordinate equal to negative root 3 over 2, because remember for cosine we're talking about x-coordinates. So in the top half of the unit circle, right there is where the x-coordinate is negative root 3 over 2. We have to go through pi over 6 radians to get to it. So this is equal to 5 pi over 6. All right, I'm going to give you a couple to work on your own. Okay, press pause while you work on these three. Okay, for inverse tangent of 1 over root 3. So here, this is where the y over the x is 1 over root 3. So we see that's pi over 6 radians. The inverse sine of 1, okay, so that's where the y-coordinate is 1. We have to go through pi over 2 radians to get to it. So the inverse sine of 1 is pi over 2. Inverse sine of negative 1, well, that's where the y-coordinate is negative 1. We go clockwise through pi over 2 radians to get to it. So the answer is negative pi over 2. Okay, here's a problem I want you to think about. So usually when we have we apply the function to something and then apply its inverse, we just get what we started with. But in the case of the cosine or the sine or the tangent of an angle followed by its inverse, we don't just get our input left, and that's because of the domain restriction. So 7 pi over 4, that is not in the upper half of the unit circle. So I know that it can't be the output of inverse cosine. So the way we would evaluate a problem like this is we would first find out what the inside equals. So we go to the unit circle looking for 7 pi over 4. And we see that it's right here. The cosine of this angle is root 2 over 2. So we would say, all right, this here is root 2 over 2. So now we need inverse cosine of root 2 over 2. So now we're looking where on the unit circle is the x-coordinate root 2 over 2. And that's right here. Okay, so the final answer is going to be pi over 4. Okay, so the inverse cosine of the cosine of 7 pi over 4 is pi over 4. So if we first, so basically to evaluate a problem like this, we can just find out what the inside equals and then treat it as like a two-part problem. Okay, so I want to write as an algebraic expression. So I have sine of inverse tangent of x. So sometimes in math, when you're solving a problem, you'll get an answer that looks like this. But it's a little easier to work with algebraic expressions when we have something like this as our answer. So writing it as an algebraic expression means we don't want any tangent or sine. We don't want any trig in it. We just want x and powers of x and fractions and stuff like that. So what we're going to start by doing is calling inverse tangent of x theta. So then we have, so theta is inverse tangent of x. Okay, so if we take the tangent of theta, we just get x. Okay, so if theta is inverse tangent of x, that means the tangent of theta is just x. So we can draw a little triangle, a right triangle that has theta as an angle. And since the tangent of theta is opposite over adjacent, and x is x over 1, we know the opposite side has to be x, and the adjacent side has to be 1. So then by the Pythagorean theorem, we can find out what the hypotenuse is. It's going to be the square root of the 1 squared plus the x squared. Okay, so that was the 1 squared plus the x squared. So now we have sine of inverse tangent of x is the sine of this angle theta here, and the sine is the opposite over the hypotenuse. So x over the square root of 1 plus x squared is the final answer for this problem. Okay, I'm going to give you one to try. Alright, so press pause while you try this one. Okay, like in the last problem, we're going to let this be theta. I definitely didn't want to do that. We're going to let this be theta. So we have theta equals the inverse sine of x. So that means that the sine of theta has to be x. And I'll write that as x over 1. So I'm going to make a right triangle with an angle theta. And I know that the sine is the opposite over the hypotenuse. So the opposite is 1. The hypotenuse is going to be x. And by the Pythagorean theorem, this is going to be the square root of x squared minus 1. Alright, so now we want to find the cosine of theta. Well, the cosine of this theta is the adjacent over the hypotenuse. Oops, divided by x. Okay, that's a theta. Right, so the final answer is the square root of x squared minus 1 divided by x.